Our first presentation today is Gilbert Hangartner speaking on behalf of Brainwork Consulting and ALPIQ. So thank you so much for being here, Gilbert. Let me hand things over to you.
Good evening from Europe. It's already late evening here. Even though I've been modeling half of my life, I just started with Quantrix a few months ago. So this is my first conference, and I'm really thrilled to meet all the people, and I'm really thrilled that I have the honor to present how I ported my Monte-Carlo simulation model onto Quantrix. I will first a little bit present on Brainwork and ALPIQ, which is my client. So what is the business question, why we do this modeling? Then I will talk why these are challenging times, like all of you know, and why Monte-Carlo simulation is a good tool to tackle these questions of uncertainties and risk. And then I will show a little bit, not into details, but give you an overview how to actually do Monte-Carlo simulation and how you can do this on Quantrix. Make you a little demo, and then in the end, maybe come back and try to explain why we are doing all this fast, why we're doing so complicated things. So let's start sharing then. I think you should see my screen. 2 words about myself. I'm Gilbert Hangartner. I have an independent consulting company quite a time now, and I'm a trained physicist. So I did quantum chemical modeling of molecular spectrums. And when you can model molecules and how they behave and how they interact with light and all these tiny little things, then you can model about everything. So I really believe that modeling helps you to understand the world, and that's what I'm doing for the last 14 years. I'm in finance risk modeling and making simulations for a lot of industries, but mainly in electricity and railway. So really industries with a lot of big investments and utilities industries. Okay. Now, my current client is ALPIQ, which is one of the biggest Swiss energy producers. So they have a production, yearly energy production of 12 gigawatt hours and installed power of 5,000 megawatts. So this is quite a lot. So this means the plants are not running all the time. There are a lot of plants, hydroelectrical plants, which just produce when power is needed, and they have all the pump storage, so the water can be reused to make power available when it's needed. So it's kind of the battery of Europe, or part of the battery of Europe, with all the hydropower plants they have in the Swiss mountains. They have also 2 nuclear power plants, or parts of it, and some thermal gas power plants to make the peak energy. So at ALPIQ, Quantrix is mainly used in corporate finance. They aggregate the budget and make budget provisions. When I came to this project, I was asked to help for my Monte Carlo experience, and they asked me to do it in Quantrix, and I wasn't really happy about this, but because I didn't think that you can do this with Quantrix. So now, what is the problem? The problem is really that the times are very changing with COVID, which was very difficult for supply chain, energy market, which is crazy. Which was already crazy last year, but we went completely crazy in Europe when the Russian aggression on Ukraine started. So just one idea, energy prices have been the last years between 0 and 50%, sometimes 50 euros per megawatt hour, sometimes even negative. So this price wasn't really enough to cover all the costs, and it really made that the investments went down. And now all of a sudden there's not enough electricity, so prices went up to 700. So you have really at least 10 times tenfold increase of the energy price. So you would think This is difficult for everybody, for industry, for consumers, and you would think this is a very good time for electricity company. It is, but not only, because first thing is you produce the energy now, but you have already sold it 3 years ago, and you have sold it for a low price, and now the price rises, so you can't really profit. On the other hand, if you lose a power plant and you have to buy the electricity now that you sold for a lower price, it can be really tough. So there's one gas company in Germany which had a lot of problems because they lost a lot of gas and they had to buy on the market very expensive gas and sell it for a cheaper price. So it's really, things are going up, and the mechanics people are used to do not work anymore. Yeah. So how do we tackle all these problems? The first point is we're really thinking in scenarios. So scenarios are either different guesses I make about the future, which future I expect. Will the war be over? Will we get back to normal? Will heavy investments start in renewable energy? And secondly, most importantly, which decisions are we going to take? So are we going to invest or not? Are we going to cut costs? Do we sell the electricity now, or do we wait for later? Are we taking more or less risk? So scenarios are the way to recalculate the same thing, but for a different set of parameters. So we change the parameters like the price we expect or the investment we do, etc. Then there are risks we cannot control. For instance, if the power plant has a technical problem, so there's a certain risk this will not produce. Credit risks, which is a very big risk at the moment because all the other partners in energy, they have the same problem as well. So they don't really know, you don't really know if you get your money, so you have a big credit risk. And so we will, all these uncertainties you will model as risks, as input distributions, and then you will calculate the model, and obviously all what is the result. So your KPIs, so your equity ratio, your EBITDA, all your KPIs you're interested in, then also will obviously distribution. So you don't get one answer, but you get a lot of answer, but you know how your answers will be distributed over the entire space. I should speed a little bit up. So I made a demo model, which I show, so it's not the real one, and the numbers are fictive. I have two elements which are a little bit special compared to normal Quantrix model to make Monte-Carlo-Simulation possible. The first is I packaged for my client a little risk library. So ALPIQ has installed this risk library, which puts all these risk functions easily at the disposition in the model. And there is a script which does then the actual simulation. It's not a complicated script, but yeah, it's quite interesting what you can do with this scripting engine. And I really hope that this will even be improved a little bit, that more is possible, because it's really a powerful tool. The good news is Quantrix and Brainwork will make soon this little MC Monte Carlo starter kit available that you can use to get started with Monte Carlo simulation if you like to do this. Okay, how is the model? Just simplified my little demo model. I made 3 countries and add them together, and you have different production in every country. They depend differently on the price. I don't go into too much details, but what is the basic thing? Like in every budget model, you make a budget for each country, and then this is aggregated on the corporate level. So that's exactly what we're doing. So nothing really new. So we're calculating the net revenue, which is very simply the production volume of our power plants times the price. Now we have 2 problems. We have the production volume is not constant, but it's it can go up and down with technical risk, for instance. So what I do, I make each power plant some parameters, and then I write the risk function. I'm not sure if you really can read it. So this is just a risk function that makes some distribution of how big the volume will be. So if there's more water or less water, you can produce more or less. If the power plant fails, it will not produce. So depending on a random generator, the production volume of the power plant will change. The same, the price or the stock market price now went up. It might be that it turns down and they go down again. So again, we modulate the price with a random generator. And so there are two things. There's one part is random, and the other part will be we choose the parameters how this randomness will be, because it can be random but going up, or random going up and then crashing. So there are different scenarios, different input parameter how we model this price level. Then obviously the net revenue is then just the product of the volume times the price. And what was really nice, what for me was very surprising, having worked on other platforms on Excel, I did the same model like this on Excel, which is possible, but which is difficult. The idea just say, well, there are 10 plants, all have the same formula. I just have to parameterize for every plant. And there's one formula that calculates the revenue. This is just amazing how easy this is. And this works all the same if you're doing normal Quantrix or if you're doing Monte-Carlo Quantrix. So there's no difference. So we have the same thing about the cost. For ALPIQ, the problem is a lot of cost is in Switzerland, but all the revenue is in euro. So the energy is mostly traded in the rest of Europe. We had another currency. And if you look at the euro, which was €1 was 1 franc 80 some time ago, and it dropped. And a year ago, it was still 110. And today it's, I don't know if this was last week, it's below 1 franc. So also FX exchange rates are very, very important, especially if you trade a lot of volume with a little difference in price. You can lose nearly more money by the exchange rate than you gain in trading. There's one last slide who explains the model. It gives you an overview. So the model is like a standard finance model. You have the P&L, you have the balance sheet, and you have the cash flow. And obviously, everything is connected. You take the standard budget, and then we put on top these different price scenarios, volatility, and so on. And then the only thing that is different, you normally would calculate one budget. You get the right numbers in, you calculate it, and you get the result. What we are doing, since we have a lot of randomness distribution in this, we do recalculate the model 10,000 times. So I recalculate the model once, then I have this magic script that takes all the data out of it I'm interested in, puts it in a result matrix, and I go over again. I calculate again, put it in the result matrix, put it in the result matrix, and when I'm done with these 10,000 iterations, then I have all the results, all these different futures in the results, which then I will analyze. So let's switch to the demo. So what you see here is the normal business model. So we have the profit and loss statement on the left on the top. We have the balance sheet, and we have the cash flow on the right on the top, on the bottom. And here on the top, we have the single plant. So one of the very important thing is how much electricity you actually produce. So as I showed you before, this is the formula or part of the formula which calculates the risk-based production volume. So which then gets here per plant and every year how much. So you see for the hydropower plant, it goes a little bit up and down, and when you have a breakdown, obviously you will lose a lot of production. So now I have a shortcut to do the calculation, recalculate. So this will give me new numbers. I don't know if you have seen it. I do it again. So we calculate. So each time I hit recalculate, the entire model will recalculate and choosing new random numbers, giving new volumes. And what you will see here, If we change the volume, then obviously we will change the net revenue. So if I go to this portion here, so you see 549, 610, it was a good year, 590. So each time we recalculate, we are calculating a new net revenue, new operating costs, everything. And this then all trickles down to the balance sheet, to the cash flow. So especially, for instance, what is very important for ALPIQ, when the energy prices go up, they need to put a lot more margins at the stock exchange, so that they will need a lot of more liquidity. So also liquidity is taken care of in this model. So this is the normal calculation, just you do it all over again. Now, I have the normal, when you go modeling, you will see the normal dashboard like this, which shows you the result and which shows you all the scenarios. So I have the scenarios, they are defined. I'll show you just quickly on the model configuration. On this configuration, you define the scenarios, you define all the input values. So we have values which are just scalars for every scenario, or then we have year-dependent values where we put in for every scenario as well. And here we have the KPIs. So we're giving a list of KPIs, which data the simulation should actually store for further analysis. And now let's add, for instance, a scenario. So this is what I really like. You just hit enter, you enter a new scenario, and Quantrix will take care of all the rest. Here is the description. We don't care. And now we would also have to enter parameters. We just take the same as well. So let's go to the dashboard. So you see here we have now 4 scenarios, and now I will do an actual calculation. It's only 200 iterations, so you don't have to wait too long. So 200 iterations should take maybe 10 seconds or so, or 5 seconds. As said, for a really final run, yeah, so we had 9 seconds for these 200 iterations. If you do a longer calculation, it will be 20 minutes or an hour or so. So nothing not feasible. So what you see now is you see these different indicators we ask for. For instance, let's look at the net revenue. So we have now 4 scenarios. You have the blue and the red one, which are basically identical, and then have a very positive one, a yellow one, which is, when we're lucky, it's very positive. So on this scale, we see on the left side the negative outcomes, the mean value, and the positive outcome just for 1 year. So we can choose to watch another year. So we see the different distributions, and we see the distribution down here as a histogram, which is maybe easier to understand. But here we see only one KPI and 1 year. And we can see multiple years with different scenarios and just give the average between the P25, the percentile, the negative, and the P75. So this gives a range. So you see here just the value, the mean value, with a little bit the range. So there are different ways to present the values, and this is then the base to say, well, literally how precise is it? And then obviously you have to check which scenario, which are the conditions I set, which are the parameters, and then you look at the outcome. So this gives you really a play to see which factors are important, which gives a good result, or which is, for instance, the liquidity need, or if you change, what is the equity looking like, or what is the cash flow. So we can look at all these indicators we can look at, and at the same time the different scenarios, and at the same time all the different probabilities, so that the range this value will spend. Okay, just last thing, as said, it's not a normal Quantrix model. It has one little, the library I showed you. So this is thanks to the plugin. You will have additional functions, which are basically the risk function, which gives you one iteration of, or one number drawn out of the distribution. And you have here the different tests I showed, and we also have a little script. We showed this. So this does nothing else basically than, well, tell the thing, we will run the simulation. We take one model calculation, we gather all the values and store them for later on. Okay, that's about it about the demo. Let's go back to the presentation. So all these fancy things, complicated. Why are we using this? Why are we doing this? So there are three main reasons. The first reason is you don't want to be surprised. You want to have a clear view about the possible outcome. And when you looked at this volatile price curve, is when you see the exchange rates, when you really see the crazy times, you don't know what will happen. The EU government decided to fix the price on this level. So there are so many possibilities, so many things that can happen that you can't give one correct answer. So basically making a budget doesn't mean anything. So the idea of this budgeting tool is really to see all possible outcomes, to see what happens when, where do you go, and to see this on all your financial figures. Also, predicting what is happening is very important. You can prepare for it. So the Swiss energy companies, for instance, went to the government and said, we really have a liquidity problem, or we might run into a liquidity problem because of these crazy exchange markets. When in 1 month the price goes up 10 times, you have to pay a lot of margining costs, so you don't have the liquidity. So you need to prepare for that. And you also can trade differently. So you can wait to sell, or you can sell earlier. So you can also adjust your risk appetite only when you know what influence it will have on your figures. And the third point, and probably the most important in most cases, is sometimes you can make decisions. Today you can make the decision if you want to invest or not. So making scenarios helps you to make good decisions. So for instance, selling now or waiting to handle the risk between profit, risk, and liquidity, or investment variance. So if you know, do I want to build solar, or do I want to build a hydropower plant? The hydropower plant can make power in the winter. The solar can make the power in the summer. What is better? What is more good for my company? So this is the use for the Monte Carlo, and now I want you to play. Not make an investment decision about power plants, that's too complicated, but just one little business case. A friend of mine asked me, he wanted to go and sell kebab on a weekend on a festival, and he said, well, how many kebabs should I try to sell? How much material should I buy? So we made a little calculation, 3 business options. The red one, buy only 1,200. Be pretty sure to sell them all, buy a little bit more, or go really crazy by 2,000. So we bought this and we calculate the risk, and the risk he might lower, have to price if somebody else comes. So we put in several risks, made a little model, and then calculated the output distribution. So this is the net profit he can make out of this business, and we plotted this on here. So now you don't have a number. So it's not, if you choose the red strategy, you will get 2,000, but you will get something between minus 500 and plus 2,000. 2,000 is if it's best case. Here's the mid case, and on the left is the worst case. So the blue scenario has the best case here, about 4,000, 2,500 for the mid case, and 2,000 for the worst case. And the green one goes down nearly to 4,000, but up to 6,000. Okay, so this is the result from the calculation. It will be the same for ALPIQ. It will be the same for all Monte Carlo business cases. Now you are the executive board, executive directors, and you have to decide. So now decide which business option would you choose: red, blue, or green. I give you 30 seconds. So the question is, Would you buy 1200 kebabs, red? Would you buy 1500 kebabs, blue? Or would you buy the material for 2000 kebabs and try to sell them? Okay. On the next, you can read, you think your color, you can read your character description, what kind of decider you are. Just read the color you have chosen. Okay. So last conclusion. Honestly, I didn't want to do this project in Quantrix. I was sure it wouldn't work. Now we're nearly done. We're prototyping stage, but we're pretty fast. And the preliminary conclusion is, honestly, it was tough. It was tough for me to learn it. But it was amazing, and I think it is amazing how fast you can do things, how fast you can test things, and how intelligent Quantrix always knows what you want and do it in most cases right. I really did not expect Quantrix to do Monte Carlo, but in fact, it's rather easy. Monte Carlo wasn't the tough part. It's now it works for all solutions. This is really ticked, this is checks. So what now really counts is having a good finance tool, a good modeler, because the model, making the model, the content is much more difficult, much more important than having the Monte Carlo simulation. Monte Carlo simulation is just a way of calculating. And all my other models have always been in my hands because they were then so complicated and technical that I had to control them. With Quantrix, I really hope that this tool will then go to the hands of the controller, that even a normal controller can use it, can change some model assumptions or change the logic of the model without really having needing a specialist. So we really had very few debugging. That's what I think was the most amazing. It was very easy to test. So I really liked working with it, and I'm really very interested how this model will then be accepted, and if it will really change the way as how ALPIQ is changing, is planning, doing the financial planning in the future. Short acknowledgements. Many thanks to Dominic Etter, Chief Controller, Group Controller at ALPIQ. He learned me a lot of Quantrix, and he learned me how to understand the business model of ALPIQ. Luca Baroni, CFO, who believed that this will work and this will help. Vladimir, who got me started with the risk plugin. So without him, wouldn't have been possible to make the risk plugin. And it's always good to know Lindsay and Ben, especially having Ben's phone number to do all this scripting. This was really an amazing support. I wouldn't have been able to do this without a good support. Sorry, it was a little bit long. Thank you very much. And I hope there's still time for a question.
Awesome. Thank you so much, Gilbert. And we do have a couple minutes left for questions. So a quick one to start off. If anyone has questions on that library, can users reach out to you if they have questions on the types of stuff that you're doing as well?
Of course. Yeah, it's easy. So it's very easy to explain. So I put my my contacts in the chat, and yeah, reach out or on answers. When you post it on the answers forum, this will be nice.
Perfect. And so we got a couple here in the chat we might be able to get to before the next one. How long does it take to do the 10,000 iterations, and do custom functions slow performance?
I think the custom functions do not slow down the performance. If they're made in the plugin, they're technically the same as the Quantrix functions, so that's not a problem. And 10,000 iterations will take about an hour. So normally you will not do 10,000 for normal working. You will just do this in the end, because 1,000 will mostly be enough. I expect the model to run 1 or 2 hours with 10,000 iterations.
And how stable are the results with 10,000 simulations?
You won't need that much. That's really, they are completely stable. You won't see a difference between one run with 10,000 and another run with 10,000 iterations. You won't see a difference.
Awesome. Well, thank you, Gilbert.